Hey, thanks buddy. See you snel. That was one of my friends and he is a legal advisor. I am allowed to talk about this. The statute of limitations has passed. Motherfucker! Welcome to Callous Coder, and today I will show you how I owned the network of my college back in 1990. With this old floppy that I found that contained some assembler files. And since I did recently an assembler coding video, I figured let's jump into the code and have a look at how I became the supervisor of my college network. So basically it's a keyboard sniffer, keyboard logger. So dear or hello, hello is Dutch, I am Dutch. And if I run scancode.exe log.txt, it would find that we had hello, and scancode. So if you were supervisor and this was the password back then, Versveld was the name of the college. It were simpler times back then. And this took me quite a while, like what is that caret sign? And then I figured out, oh, hang on, that is the shift. So even when I had the username and password, I still wasn't quickly enabled to get into it. But luckily I had the scancode file, not cat, scancode, log.txt it's called. Luckily I had that file, and with that data I could reverse engineer. Oh, that is a shift V. That makes sense. Yeah. So you see, it works. It's cool. Let's have a look at that code. So here we are in the code. I start off with reserving a couple of variables. First, the old int, that is the address to the old keyboard handling vector. We need to store that because we're going to call that after we've done our keyboard logger action. I will be logging the keystrokes into log.txt, although these are binary bytes that we're logging. This is a variable for the file handle. We're going to open a file and we're going to get back a file handle. And this, for the heck of me, I don't know why I reserved 5 bytes here, made it an array, when I only read one keyboard value, one scan code, and write one. So I guess it's my 17-year-old brain on pod, I think. I set this to 300 the stack. This is bollocks, so I can calculate the TSR. I set the TSR hard to 64 pages down below, so I don't know why this is there. Let's take that out. So and then we jump to the TSR code, so let's jump to the TSR code. And that is where the magic happens. First we stop all interrupts. And when you're starting to override an existing vector, you do not want any interrupts occurring whilst you're building your interrupt. That would end up in disaster, hanging, crashing. Then I need to set the data segment, because we have the data segment locally, to the code segment. The easiest way is to push the code segment, then pop it into DS. So then you have your data segment. And here we are saving the old keyboard handler vector. That is vector 09, that is the keyboard interrupt vector. The AH35 in combination with interrupt 21, the DOS BIOS interrupt, that will get the address of this vector 9. And it will set it in BX and ES. So in that old interrupt that we just saw declared, I will set the BX and the segment to ES, and I offset that by 2. And because it's little engine, first we have the offset and then we have the segment. Then I install my keyboard handler. So I set LX to my handler. We will jump to that function in a bit. I again say we're going to override that on vector 9 and interrupt vector 25 with software interrupt 21 will override the current pointing interrupt vector, which is 9, which is the keyboard interrupt that we want to override. Making the program a TSR that is in combination with AH31 and 21 hex. And I cannot recall why 1 is pushed there. I know that DX is the number of pages. And I figured, I cannot believe this, but when I read this, usually you would first call the interrupt 21 before enabling interrupts again. But for some reason I decided to swap it. I think I may have had some weird test issues, but basically I think my size here was too small and just didn't fix this up. That's my belief. When TSR crashes, usually this is the culprit, the number of pages memory that you reserve. If it's too big, you get into problems. If it's too small, it's instant issues. So let's go to my handler. There we are. The same thing, I first need to have my data segment point to my code segment. So I push the code segment, pop it. Then I push all the registers, which is a requirement basically every time you call a method, unless you're absolutely sure that you're not globbering any of these registers. There is a shortcut when you're coding for 386 or 286, that is push A. But since we had a lot of XTs as well in school, and I had an XTS at the time, I had to resort to doing all of them manually. Then I call an open file. So in AL60, that is 60 is the I/O port for the keyboard, and that's where you can read the keyboard scan codes from. I store that into the variable that we saw, scan code, that array of 5 characters, while we only use 1, configure. Then I write it to the file and then I close the file. These days I would probably first read the vector, store it, and then do this. So this is neater. So open the file, write the AL, and close the file. So let's look at close the file. That's the first one. That is interrupt vector 3e for software interrupt 21. And you pass in the handle. And you get that handle when it's open. Here I'm writing. So again, I get the file handle. And then when you open a file, it is the file pointer is at the beginning of the file. Now luckily there is an easy way to jump to the end of the file, that is giving AL the 2 hex value. So then the pointer jumps to the end. And this is the offset, the segments and the bytes within that file. But since we're at the end of the pointer, these can be put to 0 because there is no offset. And this of course is the software interrupt for the seek command. Then we're writing the command, that is, we're writing the byte, that is 40 hex for interrupt 21 again. And you need to have the handle in BX, the number of bytes that you're going to write, 1 byte. So I still don't know why I reserved 5, but go figure. Brain on drugs. And this is where I set the beginning address of that byte that we're going to write. And that's the scan code array we declared. Here is the open file, and I read this yesterday evening, and it's a bit tricky. It's a bit dodgy, let me put it that way. Again, I'm saving all the registers that I'm going to use, so we're not going to clobber anything. 3D in combination with 21H is opening a file. AL opens the file in write mode, and when you let the x be equal to the file name. That is the file name that you're going to be using. So in this case it was log.txt. And then we're doing a jump carry, because when you cannot open a file for whatever reason, there is an error, then the carry is set. And there is also an error code somewhere, but I just took the dirty shortcut that if there is an error, you're going to create the file. When that file is, for example, locked or write only, then this would cause massive problems, of course. But yeah, it's quick and dirty. It's a hacker code. So there you go. So I jump to the create when there is an error. So basically assuming that this file isn't there. And it's a fair assumption, because who else would make a log.txt? If the file is opened, then in AX you have the file handle. So I store the file handle in memory. And then I jump to opened, because it's open. Here we have the create of the file that is using 3C in combination with 21 hex. The attributes that you can make it hidden, for example, or read only. These are the standards. And again, you need to create the file, so you point dx to the file name variable. And then I jump to open again, because then we created it and then we can open it. We can open it and then we should not have an error, so the carry shouldn't be set. And in that case we also jump to opened, and opened is just popping the stack and returning. So that is the keyboard logger. So that is how I owned the network of my college, by creating a terminate and stay resident keyboard logger. Now, unlike Ferris Bueller's Day Off, there were no lists with grades, so I could not change my grade and easily pass. There were no tests and answers on there. What was on there was software to quickly install the engineering PCs. And these were expensive software suites like OrCAD to draw electrical schematics, Ultiboard to draw PCBs. So PCBWay, if you want to sponsor me, go ahead. AutoCAD, I got that for one of my high school friends who was studying civil engineering there. And I remember that there was a big DBase database with all the names, addresses and phone numbers of student and faculty. And me and another friend from high school, we were also blue box dialers. So we would do prank calls on the weekends to faculty and our fellow students. So that was kind of fun. But that was about the extent of my abusiveness of that network. And I didn't even charge for the software, I just charged the students $1 per floppy. That was the expense of the floppies, so no harm done, I guess. And as my friend confirmed, statute of limitations has passed, so there you go. I hope you liked this episode and see you in the next one.